MES Third Eye.
Hi everyone, I am Ashika K.A., Assistant Professor and Head of the Department of Software Development and System Administration, MES College Marampally. Today we are going to learn about linked list in data structures. First of all, let's have a look at what are static data structures. In static data structure, the size of the structure is fixed. The content of the data structure can be modified but without changing the memory space allocated to it. Static data structures provide more easier access to elements. They have fixed memory size. Array is an example for a static data structure. In this array, we have 9 elements, and each array element is pointed by the array indices. Array index always starts from 0. Here, in this case, the last index is 8. And what about dynamic data structures? In dynamic data structure, the size of the structure is not fixed. It can be modified during the operations performed on it. Dynamic data structures are designed to facilitate change of data structures in the runtime. They are flexible. Linked list is an example for dynamic data structures. Now let's go in detail to the linked list. A linked list is a linear data structure where each element is a separate object. Each element, we call it as node. Each element of a list is comprising of 2 fields. One is data field and other one is link field. The data field stores the data and the link field stores the address of the next node. The entry point into a linked list is called head of the list, head or external pointer. It contains reference to the first node. If the list is empty, the head is a null. The last node has a reference to null because it doesn't point to any other node. A linked list is a dynamic data structure. The number of nodes in a list is not fixed and it can grow and shrink on demand. Any application which has to deal with an unknown number of objects will need to use a linked list. And now let's see what are the different types of linked list. They are singly linked list, doubly linked list, circular linked list and circular doubly linked list or doubly circular linked list. Let's see how they look like. Singly linked list is what we have discussed just. And a node consists of 2 fields. One is data part and another one is link part. The link part stores the address of the next node so that that node can point to the next node. And in the case of circular linked list, the last node points to the first node. This forms a circular chain. That is the only difference between the singly linked list and circular linked list. And next comes the doubly linked list. In the case of doubly linked list, each node contains a data part and 2 address parts. One address part to store the address of the previous node and other one to store the address of the next node. In the case of doubly circular linked list, it has the properties of both doubly linked list and circular linked list. Here, 2 consecutive elements are connected by previous and next pointer, and the last node points to the first node by next pointer, and also the first node points to the last node by previous pointer. So this is the case of doubly circular linked list. That's all for today. We'll meet you in the next video. Thank you.